A plant leaf harvests solar power with near-perfect efficiency. Meanwhile, fusion reactors struggle to maintain power despite generating reactions millions of times larger. This split screen captures the discrepancy. ATP synthesis operates on 0.5 electron volts, while a fusion event detonates with 17.6 million. If energy were fuel, this yield should mean limitless power. Instead, it violently fragments, scattering into heat and instability. This 70-year bottleneck persists because we have mistaken a mathematical ledger for a physical fluid. The TCGS-SEQUENTION framework redefines energy as a functional counter. It is a bookkeeping device that tracks admissible transitions between physical states. Harvestability depends on a structural metric called corridor dominance, the ability to route a counter update through a protected pathway without it leaking into competing channels. Solving the fusion crisis requires navigating energy as a topological transition graph rather than trying to bottle a substance. To understand this ledger, we must separate the territory from the map. The territory is a timeless, four-dimensional structure called the counterspace. What we observe as time and motion is the shadow, a three-dimensional slice-by-slice readout of that static geometry. Energy is a map-level functional. It is a number computed from shadow-level observables to track the constraints governing which physical transitions are allowed to happen next. Emmy Noether proved that energy conservation is a mathematical consequence of structural symmetry. The counter balances because the rules of the structure require it to do so. This changes our view of the electron. Standard narratives treat electrons as tiny piggy banks that carry physical energy around a circuit. In this framework, electrons provide the teller's window. At chemical scales, electromagnetic coupling is the most accessible channel, making electrons the most efficient interface for updating the boundary conditions of the ledger. This abstract node graph shows photon absorption. A glowing point on an environmental electromagnetic branch maps its value onto a material branch. This is a transversal rebinding. The graph reorganizes its connections across a boundary, swapping the constraint from one sector to another. The counter is perfectly preserved as the system changes the encoding from the environment sector to the material sector. All observable energetic events are ledger updates at boundaries, a fact that dictates how we must engineer physical interactions. Photosynthesis operates as nature's ultimate corridor dominance machine, converting a fleeting optical event into stable storage with near-total efficiency. This directed pathway graph shows the process moving through protected encoding swaps. The photon is re-encoded, passing down a terraced gradient into charge separation. Success depends on corridor dominance. The downward pathway thickens to overwhelming probability, while horizontal leakage channels shrink to zero. Ultra-fast structural gating at the reaction center escorts the counter through the corridor before it has a chance to escape through a back reaction. This coordination creates a massive accumulation of protons on one side of a pulsing lipid membrane, establishing a stable proton motive force. The proton motive force functions as an accumulating geometric asymmetry across the lipid bilayer, rather than a stream of flowing energy.
A biological membrane functions as a structural vault, prioritizing geometric stability over the volatile chemistry of a battery. This vault maintains the cumulative invariant imbalance long after the initial photon's encoding has vanished. Biological survival relies on geometric pathway gating and stable storage, rather than the pursuit of high-yield volatility. While plants have mastered this gradient, engineering humans to photosynthesize remains a mathematical impossibility. Human metabolic demand requires roughly 100 watts. The harvestable solar flux hitting the surface area of human skin yields at most 1 to 10 watts. Human tissues also lack the specialized gating corridors required to process that flux. Without them, absorption events would route into catastrophic photochemical leakage and cellular damage. This requirement for structural gating scales to the physical failure case of tokamak fusion plasmas. Here is a 3D topographic surface. The left shows sharp potential wells of stable chemical bonds. The right shows a fusion reactor, a vibrating plane of billions of dots. Acting as equal anchors, they erupt into chaotic interference, destroying any straight paths across the plane. Plasma turbulence manifests as an interference artifact produced by a low-gradient configuration space rather than a failure of magnetic containment. Achieving harvestable fusion requires identifying or engineering dominant singularities within the plasma to force a stable corridor through that interference. The conceptual test for the functional counter theory is the equation E equals mc squared. A common public misconception holds that this formula proves mass is a physical container overflowing with a fluid energy. The equation actually serves as a translation tool, mapping a timeless four-dimensional invariant, mass, into a three-dimensional observable functional, energy. This diagram shows the geometry of that translation. A glowing 3D plane slices through a dense 4D hyperstructure at a Locke angle. The angle of that slice, theta, determines the outcome. Its tangent squared morphs into the familiar c-squared variable, a geometric slicing ratio. The seconds we use to measure the speed of light are operational renderings created by shadow-level clocks, rather than markers of an ontic temporal dimension. The speed of light is a structural consequence of how 4D geometry is projected onto our 3D slice. This reinterprets E equals mc squared as an exercise in cartography, mapping static 4D geometry into dynamic 3D accounting, and providing a structural alternative to the energy-substance narrative. The extrinsic constitutive law reveals the underlying structural logic of human technological progress. Every historical technology harvests power by exploiting high-gradient, singularity-dominated physical regimes, where one clear source anchors the landscape. Unharvestable systems, like fusion reactors, fail because they lack these anchors, dissolving into multi-source interference. Progress requires moving away from building bigger walls to contain chaotic, imaginary fluids. The new engineering imperative is to restructure configuration spaces to create engineered dominance corridors. Energy only tracks which physical transitions are mathematically admissible. The counter tells us the cost of a transition, but the invisible geometry of the territory decides what is possible.